Alright, geometry, this video is to help you fill out your circles graphic organizer. You should have picked that up in class today from the sub, so if you don't have it, you need to stop and go ahead and go get that before you watch the rest of this video. Remember that you can use this on the test. May use on test. Okay, so you want to make sure you fill this out really thoroughly. You can also add any other notes or anything that you want just on the front side of this page, so whatever you can fit on there, and so the back side should remain blank. So we started the unit talking about angles, okay? The very first type of angle that we talked about was on the inside of the circle, and it was called a central angle. Okay, important thing about a central angle is that the vertex of that angle, in this case A, is on the center. So if you were to name this angle, this would be angle BAC. The measure of this angle, the central angle, is equal to the measure of the arc. So if this angle is 80 degrees, then this arc is also exactly 80 degrees. The second type that we talked about was the angle that's on the circle, and that's called the inscribed angle. Okay, inscribed angles, that vertex should be on the circle. So this will be angle ABC, and the arc that it's forming is called arc AC. It's a minor arc, so we only put those two letters, the two endpoints, with the arc symbol over the top of it, okay? Now, it does also create the major arc, and that major arc starts at A, goes the long way around to C. And so remember, when we write out a major arc, we want to use those two endpoints, A and C, and we want to use just one other point that you pass through, and so in that case that would be B. So the major arc here from A all the way around through B up to C is arc ABC. So these inscribed angles, the measure of the angle is going to be half the measure of the arc. So hang on just a second, let me grab a highlighter. Okay, so just to recap and make sure everybody's with me, what I'm talking about is this inscribed angle and this arc. Okay, that minor arc is going to be is going to be double what the angle is. So if this angle is 20 degrees, then the arc would be 40 degrees. Okay, or you could have gone the opposite direction. If the arc was 40, half of that is 20 for the angle. So that angle is always going to be the smaller one of the two. Okay, and then on a different day, we talked about the angles that are on the outside of the circle. For any of these angles, you use this formula where the measure of the angle equals the far arc minus the near arc divided by 2. And so there are three different types that we talked about. The one that's created by two secants, the one that's created by a secant and a tangent, and the one that's created by two tangents, okay? So they all use that same formula though. So if we look at this first example, it's got some algebra in it. So plugging into our formula, it starts with the measure of the angle. 30 equals, start with your far arc comes next, so that's 5x plus 10 minus, then your near arc, put that in parentheses, okay, 3x plus 4, because remember you're going to have to distribute that negative out, divided by 2, okay? So to solve this out, you want to make sure that you multiply by 2 on each side, and then you're going to distribute that negative out, okay? You can keep working that out in the little space that you have, or you can just kind of leave it at that to give you a little thing to get started if you need the reference on your test. So the next one is the angle created by a secant and a tangent. So same concept here, we're doing the far arc minus the near arc. So as we look at this one, we've got this far arc right here, and it's labeled as 200 degrees. However, our near arc is the one closest to that angle, and it's not actually labeled, but if you notice, we also have this 40 degrees, and if I put all three of those together, it does actually form that full circle. So what I'm going to do to find that near arc is I'm going to start with 360 for the full circle, and I'm going to subtract 40 and also subtract the 200. Okay, so that should leave me with 120 degrees for that near arc. And now I can find the angle X by doing the far minus near divided by 2. Okay, so that would be 200 minus 120, that would leave us with 80 over 2, which would be 40 degrees. Make sure you put a degree symbol on your answer since we are talking about an angle. Okay. All right, and then the next one is the one created by two tangents. Now remember, this one has some special properties. Those two properties are that the far arc and the near arc. Notice how in this picture with the tangents, since they're just meeting at the one point there, that those two arcs put together are completing that circle. And so we know that means that they add up to 360. So that's the first blank in the special properties. And then one thing that we also learned was that the angle plus this near arc equals 180 degrees. Okay. All right, so to solve this problem, the first thing you want to do is you want to subtract that 265 from 360, because we don't actually know right now how much that near arc is. So we're going to do that subtraction. That should leave us with 95 degrees for that near arc. And then plugging into our formula, that X would equal the far 265 minus the near 95 divided by 2. Well, let's see, I'm trying to do this math in my head. 265 minus 95, so that'd be 260 minus 90. I believe that's 170 divided by 2. All right, so now dividing that by 2 would give us 85 degrees. Okay, so that's one way to solve the problem, and that really uses this first property, far plus near, or sorry, it doesn't really use that first property. It really uses the formula up there. But we also talked about this second property, that the angle plus the near arc equals 180. So you could also set up and solve X plus 95 equals 180. That one's a little simpler to work out. And so that would leave us with 85 degrees. And so notice we got the same answer either way that we did it, okay? So just up to you, whichever method you like better. So those are all the different angles. The next thing that we talked about was segments. And this was the day that we just kind of had a lot of things pieced together. So you've got tangents, remember that meets at just one point, and radii that intersect on the circle. They're going to be perpendicular. They're going to make a right angle. Okay, so we often used Pythagorean theorem. If it created a triangle right here, we use that Pythagorean theorem to check that things were in fact tangent. The next one that we talked about were tangent segments drawn from the same point. So if we've got these two segments and maybe this one is 9, this one would also be 9, okay? We use that for those polygon problems where you had like a circle and you had all these polygons that were formed from it. That's not a very good tangent line, but these polygons, it's kind of funky, you know, but so you've got all these pieces that would be the same, like 5 and 5, 3 and 3, 4 and 4. And to find the perimeter of that triangle, we would just add all of those pieces up, okay? Add the 5, 5, 3, 3, and 4, 4 to get the total there. Okay, and then we also talked about When a chord and a radius are perpendicular, then the chord is bisected, okay? So in this picture, your chord is that AC. I know it's really small and hard for you to read, probably. And, but I'm trying to zoom in so you can see a little better. Knock my phone off the stand. Okay, there we go. So there's your chord AC, and then your radius here is this one, okay? And so the radius splits that chord in those two equal parts, so it has those congruent marks, but you might want to make that a little bolder. We did talk about in class a few things that might help with this, these types of problems. So I would start by number 1, looking for those congruent chords. Okay, and that's what we just marked here. So like this chord might be 8 and that one's also 8. Okay. Number 2, we said look for congruent radii. Okay, so if you had another radius drawn here and maybe we already knew this radius was a total of 10, then that means that this radius is also 10, okay, or anywhere else that you drew in radii, they would all be that same length, okay? All right, if we do all that and we're still not sure, can't solve it, then you might need to try Pythagorean theorem, okay, to get the missing side of a triangle, okay? Like in this picture, maybe if you were looking for this length right here, not the whole radius, but just that section of the radius right there, then you would have to set up Pythagorean theorem using the 8 and the 10 to solve for that piece, okay? All right, you've also got some other formulas listed at the bottom of your page. And so we talked about arc length and sector area, just plugging into those formulas. You've got the equation of a circle as well as the distance formula. We often use that distance formula to find the length of a radius if we weren't told what the length of the radius was. And then midpoint we often used to find the center of a circle. Maybe if they gave us given 2 points on the diameter. Okay, or maybe, well, really rather, I should say the 2 endpoints of a diameter, okay? And so if that's the case, we can use that midpoint formula to get the center of that circle, and then we might still have to use the distance formula to find the radius, okay? All right, so there you go. I hope that helps a little bit. I will also post a picture of this key to Schoology, so if you need to copy it down off of that picture, you can. And now feel free to go in and add any notes that you want to the little blank space that's left on the sides and stuff, if there's other notes that you want to have. Y'all send me messages on Schoology if you have questions, and I'll be glad to make some more videos if I need to, okay? There's tutoring during Tiger Time on Thursday in room 1239, as well as after school on Wednesday. I know it may be Thursday when you're watching this video, but if you see it before now, before Thursday, then after school on Wednesday, there's also tutoring. Y'all have a great day. Bye.